haven't checked our answer yet. We got a positive 1.6 and a negative 4.6. But if, yeah, the negative, you can't have natural log of negative 4.6, so that dude would be out of there. All right.
So what happens if they both cancel?
You have no solution. That can't happen. Not real often, but it can happen. Okay, so your answer is 1.6 in this case, yes. Okay, so now let's go reverse. Suppose I start you with a problem with E and I want to go the other way. No, not particularly. Okay, the mistake people make on these is this very first step. You gotta get E by itself, then you add natural logs to get rid of it.
Yeah.
You could go exponential form. I personally think people get confused. So in this case, how would I get E by itself? How do I get rid of 2? Yeah, you divide 2 out. So you get your E all isolated, E's alone. Then we need to solve for X. We need to get X down out of the power. And if you're working with an E, the easiest way is to use a natural log. So now if I natural log both sides,
Why is natural log
because in most Latin-based languages, the adjective goes after the noun.
Which is kind of weird.
Just to us. It's perfectly normal to Simone. So now when you have natural log and E, they cancel. So you lost the natural log and E. On this side, though, you did not lose the 16. Caleb. So now, last but not least, how do you get X by itself? You'd have to add 5. Okay, am I adding 5 to 16?
Yes.
No, that 16 is inside the log.
Yeah.
I'm adding 5 outside of it. You can't add numbers to inside of a logarithm. And then you're going to divide by 2, and you're going to put that whole thing in your calculator and get a decimal answer.
Wow, that's neat.
And we are going to cheat this time. And actually, I have my notes done in 3 decimals, so I think you're supposed to be doing 3 decimal places. So you should get 3.886 if you plug that baby in. So just you put it in the calculator. Yes. Yeah. Okay, realize there you just solved an exponential function. So that's an exponential function with an E. E ones are easier. Actually, anything you see with E's and natural logs are probably going to be easier than regular E. So how do you solve an exponential equation that's got just numbers? You do. Very happily. Okay, now, on the first day, I told you to make common bases.
Oh, my goodness.
But can you make common bases with 4 and 75?
Yeah.
There isn't a common base with 4 and 75.
You add a 3 to each side.
No, you can't.
75 to an edge line. You can put an E on each side. You
have to use logs. We need to get the X down out of the power so we can solve for it. So this is where we did the logging and plugging all the time.
Oh, yeah, you add a log to both sides.
Yes.
Oh, yeah.
You add the log to both sides. And actually, this is your choice. Because your calculator does any kind of log. I did common, but you can do natural logs. You can use whatever type of log you want, as long as you use the same on both sides.
Use natural. That's the way, just in case you gotta cancel it.
So I don't care. You want me to do it with naturals? It makes no difference. You get the same answer in the end. Okay, so now the idea was I could move what? Okay, the whole idea is that I can use that plug rule and I can take the exponent and I can move it down front. Okay, but when you write this, remember that's a quantity, so that's 2x plus 3 times the log of 4. Okay, if I didn't write that parenthesis, if I don't write the parenthesis, you see this. And that makes it look like the 3's with the log, and it's not. So be sure you put parentheses on your quantities or you'll be looking at the expression in the wrong way. Okay, hang on a second, Colin. Okay, Colin wants to divide by the log of 4. Cody. I want you two on opposite corners of this room. I don't care. I want you opposite away from each other. I mean next class. I don't have time to mess with you moving now. So yes, Colin's right. I don't want that log of 4 over here with my x. I'm going to get rid of it. I want it on the other side, out of the way. So yeah, that means you're only left with 2x plus 3 equals this icky fraction. Okay, now some people are tempted to go turn that to a decimal right now. My issue with that is if you turn it to a decimal now, you're going to round it off and create error. Then you're going to do other calculations and you're going to round off again and you're going to create more error. So I would prefer you don't turn it to a decimal until you do it all at once at the end.
Oh, yeah, then you subtract 3 and then you divide by 2.
There we go. You subtract 3 and you divide by 2 and then you love your calculator.
My calculator is going to commit suicide after this, I know.
Nice, happy as a clam. This is entertainment.
Clams is very happy. Clams is nosy and
Your calculator likes to be challenged.
and sit at the bottom of a
Not mine.
Until it's mine breaks. Yeah.
My calculator like me. No,
Be sure in your calculator you realize that your calculator is going to pop parentheses on these, so your numbers are all going to end up in parentheses every time you hit a log.
You got to put 2 fractions apart.
And you're going to get, when you actually calculate this one then, it actually comes out to a tiny decimal of 0.057 when you put that in the calculator.
All of that we get done.
For a tiny decimal.
No, that's it.
Okay, I told you.
Yeah, the close. Sure.
Hey, Miss Meyer, what's the probability a clam makes a pearl?
I have no idea.
Cody didn't, he thought that was the best. That makes me laugh. He thought he would make pearls. Now everybody's gonna look down upon
Yes, yes, 1 log. Oh, on this kind of when we don't write it. Thank you. When there's no base, it means 10.
Are you trying to pause that score?
When mathematicians are lazy. And so they don't want to have to write log base 10 all the time. So they said when it's base 10 because they use base 10 so much, they said we're just going to write log. And anytime it's plain log, it means base 10. Your log key on your calculator. If you do log, if you don't put a base in, it'll work.
Start writing 10 in space 2 if you're doing
Why can we make it base 10? I'm really confused on why we didn't do it. When we had it up there, we were in logarithmic.
Okay, you can do it with log.
Wait.
It doesn't matter. You could have put natural logs right here, and add natural logs all the way through it, you still get the same answer.
Why should we write it?
Okay, you've got to get this. Are you wanting to turn it to exponential form? Reverse it back out of exponential back to logarithmic?
Yeah, that's what I'm saying. Why should we not do that? Like, we're trying to put that thing on that side, that way it's already an equation, and then have it log base
Steal
4.
that from the boyfriend?
Well, today actually, since the advent of these calculators, we probably could on that problem. Usually your calculator didn't do base 4 logs. You could only do commons or naturals. So we didn't do, we had to. You have to stop and think about that though. Is that going to get you later if you did it that way?
I feel like I was looking at it and I thought it would be easier to just do with that.
I am? I didn't realize I turned it back on. 1, 2, 3, 4, 5, 6 lines. Okay. People look at this problem and want to go do all kinds of fancy things, and this is actually an algebra problem. The big thing is the fact that you have 2 e's in one problem.
So that'd be, would that be 3 e
No, but you gotta,
g
wouldn't that be a
2x
flog?
squared?
You can't plug, there's no logs.
That would be 3
Yeah,
But
move it over and put a natural on the.
if I move it over, if I did that, I would have 28 minus 3e to the x. When I natural log it, I would have a natural log of all of that together in one lump. You can't do it separate. You can't. That's not the e. That's like e squared and e to the first power. That's 2 different variables, 2 different powers. Close. Subtract the 28, and it doesn't look like it, but it's in what we call quadratic form. It follows the pattern of a quadratic. It's something squared, something to a first power, and a constant. This thing will factor. You can factor it e to the x and e to the x, because when you multiply, you add the powers. What's x plus x? 2x. And yeah, it's just plus 7 and minus 4. It'll factor and solve really easy, but people don't see the factoring and they do all kinds of weird and strange things. But yeah, it's that simple. Now you just solve your factors and you got it.
Oh, the 3x of the x. Okay, I got it.
Yeah, because that'll be 7e minus 4e, which will make 3e in the middle.
Jumped in the head, but I got it.
Okay. So when you're going to set them equal to 0, there's a, let me make sure you see one shortcut coming. When I move that over, now how do I get rid of e and get x solved for? Now, what kind of log? Now you natural log it. Okay, can I have the natural log of -7?
No.
Nah, so that's a bad answer. You can't have the log of -7.
So you get a natural log of 4.
But here it will end up being a positive 4. So then, yes, when I natural log it, I will have x equals natural log of 4. And that's a good answer because it's positive. And then you can decimalize it to 1.386. You would put that in your calculator then. Okay. Okay, what you're doing C, D, and E from last assignment. Then you're going to have to write me a note on this paper that you did them on the other paper. Okay, you cannot. I think it's just a handout. Yeah, you are going to get the handout because I didn't get to do the word problem, which means you're going to have a everything but the handout.